The B-2 Spirit is not just an aircraft. It is a silent weapon, designed to strike without being seen.
Unlike traditional aircraft, the B-2 was designed entirely in digital space, where every curve was shaped to defeat radar. The flying wing design removed traditional fuselage shapes, turning the aircraft itself into a stealth weapon. To remain invisible, the B-2 required advanced materials that could absorb radar while surviving extreme flight stresses. Each composite layer was carefully placed and cured under controlled conditions to create strength without sacrificing stealth. Unlike conventional aircraft, the B-2 was assembled as a single, seamless flying wing. Radar-absorbing materials were applied in ultra-thin layers, where even microscopic flaws were unacceptable.
The engines were hidden deep inside the wing, reducing both noise and heat, making the aircraft nearly impossible to track.
The B-2 Spirit was born inside one of the most secretive manufacturing programs ever created by the United States. With a smooth departure, the B-2 Spirit lifts into the sky.
Before assembly begins, every material is inspected with extreme precision, ensuring it meets the strict structural and stealth requirements of the B-2 program.
Layer by layer, composite materials are formed to create structures that are both incredibly strong and nearly invisible to radar. Inside high-pressure autoclaves, these components are cured to exact tolerances, locking strength and stealth into every section. Internal structures are aligned with laser accuracy, forming the hidden backbone of the flying wing design.
Panels are bonded instead of riveted, eliminating gaps that could betray the aircraft's presence to enemy radar.
The stealth coating is prepared with extreme care, using radar-absorbing compounds blended to exact formulas.
Each microscopic layer of coating is applied evenly, allowing the aircraft to absorb radar energy instead of reflecting it.
The engines are buried deep inside the structure, designed to suppress heat, sound, and infrared signatures.
Advanced avionics transform the bomber into a thinking machine, constantly balancing itself during flight.
All weapons are carried internally, preserving the bomber's smooth shape and preventing radar detection during combat missions.
The B-2 manufacturing process begins long before metal is cut, inside classified design facilities. Engineers simulate radar behavior digitally, eliminating detection risks before production even starts. Aerodynamics and stealth are balanced through millions of virtual flight calculations.
Even minor weight imbalance could expose the bomber to radar or destabilize flight.
Materials are tested under extreme stress to replicate real combat conditions. Engine heat signatures are minimized long before physical installation.
Sound levels are engineered down to near silence.
Prototype sections validate the design before final manufacturing begins.
Titanium alloys form the structural backbone, offering strength without adding unnecessary weight.
Every component is machined to microscopic tolerances, measured in thousandths of an inch. Composite materials are stored under strict environmental control to preserve stealth performance. Each composite layer is positioned by hand, where human precision still outperforms automation. Vacuum sealing removes air pockets that could weaken the structure or reflect radar. Autoclaves apply intense heat and pressure to permanently bond composite layers.
After curing, every panel is inspected for hidden flaws invisible to the naked eye.
Even the edges are shaped to scatter radar energy away from enemy sensors.
Internal ribs provide strength while maintaining the bomber's seamless exterior.
Laser alignment ensures perfect geometry across the flying wing.
Quality checks are repeated at every stage to eliminate failure before it begins.
Only approved components move forward in the B-2 production line.
Individual wing sections are joined to form the massive flying wing structure. Bonding takes place under strict temperature and humidity control.
Every surface is refined until no seam remains to reflect radar.
Hidden reinforcements maintain strength without compromising stealth.
Even microscopic panel misalignment can increase radar visibility.
Special lighting reveals defects smaller than a human hair.
Radar-absorbing materials are prepared in exact chemical proportions.
The first stealth layers begin, transforming the bomber into a radar ghost. Stealth effectiveness depends on perfectly uniform layering. The coating is cured to permanently lock in radar-absorbing properties.
All wiring is shielded to prevent electronic interference. Electronic systems are protected from external and internal interference.
The engines of the American B-2 Spirit bomber are installed deep inside its structure to suppress heat and sound.
Special exhaust channels cool hot gases before they ever reach the outside air.
Infrared testing ensures the bomber remains invisible to heat-seeking sensors.
Sound-absorbing structures reduce the bomber's acoustic footprint.
Avionics systems act as the brain of the American B-2 Spirit bomber.
Fly-by-wire technology keeps the flying wing design stable in flight.
Integrated sensors constantly monitor the bomber's environment.
All weapons remain hidden inside to preserve stealth.
Hydraulic systems are tested under full combat pressure. The bomber is stressed to simulate real combat conditions.
After years of precision manufacturing, the bomber is cleared for rollout.
Every internal structure is verified, measured, and approved with absolute precision.
This invisible skin is what allows the bomber to disappear from enemy radar. After coating, every surface of the B-2 is carefully inspected to ensure all firepower is concealed, calibrated, and sealed without leaving a trace. With the structure complete, ground crews begin final system preparations before flight testing.
After years of precision manufacturing, the B-2 Spirit finally stands complete.